Steam and ice. The science behind Bison's winter breath. The enigmatic plumes of winter's giants as winter casts its silent, icy spell across the vast, undulating plains. A truly mesmerizing phenomenon unfolds. With every powerful, measured exhale, the majestic American bison release colossal plumes of what appears to be smoke or steam, billowing dramatically from their nostrils. It's a breathtaking visual spectacle, a stark, almost primal reminder of their immense internal warmth battling against the biting, unforgiving cold. But what exactly is this ethereal, visible breath? Is it truly smoke? Say, and what are the elegant, yet simple, scientific principles at play behind this captivating and constant display in nature's grandest frozen theater? The ubiquitous principle of condensation, water in the invisible air, at its very core, this dramatic visual is a stunning, large-scale demonstration of a fundamental scientific principle we encounter daily: condensation. Our own breath, and indeed, the breath of nearly all mammals, is not just air. It's a complex mixture, richly saturated with moisture, specifically water vapor, which is an invisible gas. This water vapor originates from the warm, moist environment of our lungs and the intricate network of our respiratory system. The magic, the moment the invisible becomes visible, happens when this warm, invisible gas encounters a dramatically colder environment, triggering a rapid, beautiful transformation. The bison's internal furnace, a powerful engine of warm, moist air. Imagine the bison as a colossal, living furnace to fuel their immense bodies, to maintain their vital functions, and most critically, to withstand the profound chill of an extreme winter. These magnificent creatures generate enormous amounts of internal heat. This physiological marvel means that the air they draw deep into their powerful lungs becomes thoroughly warmed and saturated with moisture, reaching a temperature very close to their core body temperature, typically around 39 degrees Celsius, 182 degrees Fahrenheit. So, with every powerful exhalation, they release a concentrated, voluminous burst of incredibly warm, humid air directly into the frigid atmosphere. The drastic contrast: cold, external air, and rapid cooling. Now, consider the ambient air temperature during a North American winter. It's not uncommon for it to plummet far below freezing, often reaching 4 to 22 Fahrenheit, and sometimes even colder in extreme blizzards. When that column of warm, moisture-rich air from the bison's lungs hits this drastically colder, a rapid and dramatic cooling process. The invisible water vapor within the exhaled breath loses its heat almost instantaneously, a process that happens in mere fractions of a second. From invisible gas to visible droplets, the transformation explained. As the warm water vapor cools with astonishing speed, it rapidly reaches what scientists call, this is the critical temperature at which the air can no longer hold all the water vapor in its gaseous form. At this precise moment, the excess water vapor undergoes a phase change. It condenses, transforming from an invisible gas into millions of incredibly tiny liquid water droplets. If the ambient air is exceptionally cold, these tiny droplets can even freeze almost instantly, becoming minuscule ice crystals. It is these countless microscopic liquid droplets, or ice crystals, suspended in the air that collectively scatter light and become perfectly visible to our eyes, creating the dramatic steam, or smoke effect we observe billowing from the bison. Smoke effect we observe. The grand scale. Why bison's breath is so profoundly dramatic. The reason a bison's visible breath is so much more striking and voluminous than, say, a human's is a matter of sheer scale and physiological capacity. A bison's respiratory system is vast. Their lungs are enormous, allowing them to process and expel immense volumes of air with each powerful breath. This means they exhale a significantly larger amount of warm, moist air compared to smaller animals. Consequently, the volume of condensing water vapor is far greater, leading to a much denser, more expansive, and profoundly pronounced plume of visible condensation. It's a grand, dynamic display of basic physics and thermodynamic principles, brought to life with breathtaking power and elegance by one of nature's most magnificent and robust creatures, a scientific marvel, a symbol of adaptation. So, the next time you witness the breathtaking, ethereal plumes of a bison's winter breath dance against a backdrop of ice and snow, remember, it's not smoke, but a simple yet profound scientific marvel. It's the invisible becoming gloriously visible, a testament to the intricate interplay of temperature and moisture, and a striking, beautiful reminder of the incredible physiological adaptations that allow these powerful, ancient animals to not just survive, but to truly thrive. Even in the very harshest, most formidable of winter landscapes, their breath is a silent, constant declaration of their enduring power.